Hello, let's take a quick look at section 6.6 in Math 100. This is all about graphing linear equations. Most of us have graphed before, but it might have been a while. So we're going to take a look at a couple things like just the plotting points, using intercepts, finding slope of the line, that kind of thing. When we are graphing like this, we are using what is called the Cartesian coordinate system. The quadrants are named in counterclockwise order, 1, 2, 3, 4. The center we call the origin. If you go to the right, it's positive. If you go to the left, it's negative. The first value is for x. Then you go up or down for y, depending upon whether they're positive or negative. The horizontal line, again, is called x-axis, and the vertical is called the y-axis. They cross at the origin. So we plot points by following the direction. If it's 5, 3, we go to the right and up. If it was -5, -3, we would go to the left and down. Here they have 3 points that we're plotting, and we're trying to figure out what the fourth point would be. Remember that when we're talking about a parallelogram, the sides are equal length and kind of the same distance apart. So they're determining that there might be 2 different solutions because these both have to be 5 units long. Now, when we want to graph an equation, we're going to plot points. And so we're going to call these a linear equation in 2 variables. You technically only need 2 points to graph the equation. It's always a good idea to plot a third one to make sure that you're in the right spot. It helps to solve the equation for y, like y equals 4x plus 2, y equals -3x plus 1, things like that, and then find some values for x and plug them in to get y. So here we're going to look at y equals 2x plus 2. So we make this little chart. Maybe back in high school, your instructor called this a t-table or a t-chart. But basically, you choose the values for x. These are arbitrary. 0, 1, -1. A lot of times we used to say -2, -1, 0, 1, 2. You pick the values for x. You plug them in this equation to find out what y would be. So if x is 0, 2 times 0 plus 2 is 2. If x is 1, 2 times 1 is 2 plus 2 is 4. But now I've got some points. So I'm going to plot them. Remember, I start at the origin. -1, 0, 0, 2, 1, 4. And then they all fall in a nice tidy line. Please note, I do also have a separate video about how to use the MyLab graphing tool that will help you make sure that you plot your points correctly. A different way to graph is to use intercepts, where the lines cross the x or y axes. So for example, if you have an equation like 2x plus 3y equals 6, you might have seen that I just clicked past the how to do this part. You let x be 0, solve for y. Let y be 0, solve for x. In other words, you're forcing it to be intercepts. In this equation, if x were 0, then you would have 3y equals 6. If y were 0, you would have 2x equals 6, and you would be able to solve. Find the x-intercept, you let y be 0, 2x equals 6, x is 3. So that's one of your points, 3, 0. The second one is let x be 0, solve for y. Now you have another point, 0, 2. And you can plot those and even do a checkpoint if you want to make sure that they all fall on a straight line. Now slope is the steepness of the line. It's basically how much is the y value changing and how much is your x value changing. It's a ratio of those two. Or what we would say is vertical change or horizontal change. Of course, we often think of this in terms of real life like something like a wheelchair ramp or the roof of a house, something like that. If you skateboard, of course, a ramp for that. But you want to find the change in vertical height over the horizontal change. Or if we're computing, it's y from the second point minus y from the first point, or what we call y2 minus y1, divided by x2 over x1. Or you might see this symbol, which simply means delta or change. If your slope is positive, it rises from left to right. If it's negative, it falls from left to right. If you have a flat line, the slope is 0. And if you have a straight up and down line, you can't define it. Imagine if you're driving down a road and you saw a road in front of you that went straight up in the air. You can't travel that. It's just untravelable, if we'll say it that way. So it's undefined. Let's find the slope. Okay? So this is y from our second point, y from the first point, x from the second point, x from the first point, and we're going to substitute those in. 5 minus a negative 3, 1 minus a negative 1. Watch your integers. We have 8 over 2 or 4. That means for every 1 that x moves to the right, y moves up 4. That's what the slope is. And you can see that when you plot your points. If you have an equation in the form y equals mx plus b, we call this slope-intercept form, like y equals 3x plus 2. The coefficient of x, the number multiplied by x, is your slope, and this is your y-intercept. So that's kind of a shortcut to graphing sometimes. So for example, if you can get an equation in that form, it might help you graph. So for example, here we go first. 4x minus 3y is 9. I want to solve for y. So the first thing I need to do is subtract 4x from both sides. Then I'm going to divide by the negative 3 so that I can just have y equals and everything's on the other side. Once I've done that, notice now, I know my slope is 4 over 3 and I know my y-intercept. Y-intercept means where my graph is going to cross the y-axis. So I'm going to have a slope of 4/3 and a negative 3 is my y-intercept. So I can plot the point 0, negative 3 and then go 1, 2, 3, 4, 1, 2, 3, or 1, 2, 3 to the right and then up 4 to get a slope of 4/3. I can also use that in reverse to determine the equation of a line. Here the intercept is 1, and look at the slope. It's going to be negative. We can tell that from the graph. And if we go right 3, if we go right 3, we go down 1, which means our slope is negative 1/3, and my y-intercept is 1. So it's negative 1/3 x plus 1. When you have horizontal or vertical lines, you'll only have one variable. If you have, for example, y equals 2, that means y is always 2. It doesn't matter what x is, y is always 2. That's a horizontal line. If x is always negative 3, it's always a vertical line. You may have heard the terms in the past dependent and independent variables. When we talk about x, that's the independent variable. Y depends upon it. So you pick values for x, and the system you solve for then is y as